Thank you, Martin. Today we'd like to visit a little bit on the use of on-farm software computerized solutions to monitor the performance of just not only the milk meters but also the milking system. I wanted to make a few comments on the changing dynamics in herd recording. Traditionally, our herd recording programs in the U.S. and I think many other countries have relied on the use of portable meters that are owned by our herd recording organization. And of course, with that ownership, there was a control of meter maintenance, meter calibration, and in many cases, meter operation. Our recording organizations also had to carry that investment in that equipment. What we're seeing now in a new construct of herd testing is a smaller number of herds coupled with increased herd size. And there's a desire for immediate access to both data that was measured and results. I think we've heard that many times over this meeting. Also, we see increased investment in basically the milking systems, software by the dairies, and there's this desire for increased labor and data handling efficiency. And I think finally one other item that we do see is the desire to use multi-day milk yield averages in our recording programs, pulling that data from the farms. As a little background, just wanted to share some statistics from the U.S. As in many countries, we see a declining number of herds. These are the herds on DHI programs, which would be recording programs in the U.S. And a similar graph for the same time period for the number of cows participating in herd recording. But what was really important is that 4.4 million cows, you can see the distribution in herd sizes. And if we look here, nearly 2 million cows reside in herds that are greater than 750 cows. The range in herds that are on official herd recording in the U.S. goes from small herds of 1 to a high of 52,000 cows on 6 sites in 2 states. In fact, that group of 1 million cows and 2,000 plus cow herds represents 152 herds and about a 6,900 cow average. And as you can see, the average size of our herds have been increasing, as in many countries. The last 6 years, we've seen some more significant increases than we had in the previous 10 or so. Just a little bit about the meters that we're using in the U.S. When you look at the meters on the left side, those are those portable meters or monthly meters that are owned by our field service organizations. In the U.S., we have 25 of them that provide field services. We've seen a slight decline in the number of portable meters, mechanical meters that they are using. And each of these meters is calibrated on an annual basis by a water test. Where we've seen the biggest change is in those meters that we could call daily meters or meters that are owned by the dairy. And we've seen an increase, an almost doubling in the last 4 years of those meters that are being used. And I think part of that increase can be attributed to herds that are increasing in size and increasing the size of their parlors. Part of that increase is our field service organizations finding ways to use those meters in their services there. With that, I also kind of expressed on the bottom right there the percentage of meters that are calibrated either by a traditional water test or by what we are referring to as a statistical or a meter performance report. And you can see that number basically is increasing. We've had more meters monitored in the last year by statistical reporting than we had in all of 2008. So. Couple quick comments on the calibration of our daily meters or dairy-owned meters. First of all, a water test installation is still a requirement. We need to make sure that the meter is working right and the entire milking system is operational and providing us good data. The real question is, what do we need for ongoing calibration? Obviously, an annual water test is the standard, a current ICAR standard, and a standard in the U.S. certification program, but it may not be enough. We have a higher usage level of these meters, 24 hours a day in some cases. These meters have milk running through them. They may only be shut down for 30 minutes for a cleaning, sanitizing cycle. There's also some concern from our field service organizations that there's no real oversight of meter maintenance, software updates, and what's the accuracy of that data on each recording day. And finally, there's a significant cost to either haul in portable meters, in some cases 100+ meters, install them just to conduct a test. There's the expense of trying to calibrate these meters and the time that's involved, and there's a true labor cost that our system has to bear. One thing I wanted to point out, and it's a presentation that my colleagues from the US have heard me say before, even though we call this a meter performance report, it's just part of a linked system on the farm. Yes, it's central to an ICAR-approved calibrated meter, but really it's a linked system that includes a functioning milk controller, interfaces that are communicating with software, either manufacturer software or the use of third-party software. We have to have an accurate ID system, and of course there's a human factor involved in the system. Presentation that there's some comments that we shared previously. There's a lot of sources of error in data recording. That milk meter may operate, be calibrated, be working within a 2% tolerance. But we could have errors in the controller, a cow is missed, data isn't transferred. But what really is the sensitive area is the animal ID system. And you can see in this chart here, I just kind of did 3 quick scenarios, an excellent, a good, and a fair. And even if that milk meter is working fine, if we have errors in animal ID, it can affect the overall data accuracy from the on-farm system. I think it's important that errors also exist when we have our technicians come out and do calibration or do herd recording events. There's the potential for errors, but we really, in this case, since we're relying on the dairyman software, the dairyman's meters, review the entire system and work to minimize errors in each of these categories. Some variables to build this report, and I call it a meter performance report. I think you could call it a milking stall or a bale performance report. We need obviously a date and a unique identifier, be it a herd code, a herd name. We need animal ID. Animal ID is central to this calculation. We need to have a stall, milking stall meter ID. We need measured milk weight. We need the number of meters or milkings that are represented, and then we can calculate a deviation. In the US, we use some other, or have some other variables that are reported, more to assist us in interpreting these reports. A defined tolerance, just so everyone knows what the basis for interpretation is. Things like ID errors, missing cows, duplicate reads, cows that showed up in the wrong pen. Things that have to do specifically with milking procedure, reattachments, manual detachments, milk letdowns, milking time deviations, milking speed. So there are a lot of variables that we could include to build this report. Traditionally, this report is calculated in 3 steps, or the deviations calculated in 3 steps. The first is an expected milk weight, and basically that's the yield average for a cow over the last defined number of milkings, be it 3 days, 5 days, 7 days, and then factored for the entire herd performance at that lactation. Now, recently working with Clement in France and a few others in our group, we've modified that to compare like milkings to basically account for differences in milking time, and that has improved some of the values, and I believe Clement's going to address that. The next step is a simple calculation of a cow deviation. Basically measured yield minus expected yield. And then finally we come up with a stall deviation, which is the sum of the deviations divided by the sum of the expected yields. The next thing that we look at and have worked with is the removal of outliers from the calculation. And this is proposed in the revisions to Section 11. I'd like to thank one of our organizations in the U.S., Minnesota DHIA, provided me with multiple data sets on herds of basically every single milking for a period of days. I was given close to 100,000 data points to work with, and I do appreciate that. As you can see, most of our outliers in expected milk yield were those cows in the red that the first 30 days or so of lactation. And I think we're very justified in removing those as not to bias this prediction. You also may want to consider the removal of expected milk yields for cows that are deviating plus or minus 30%. I personally like to err on the side of including them as to look for possible deviation in the meter from performance there. Once again, emphasizing the concept that accurate ID is important. We need a stall, milking stall ID, we need a cow ID, and we have two sources of error. In our electronic ID systems, it's a technological error usually, non-communicating transponders, antennas, or readers failing, or in systems where we rely on manual ID entry. The milker is keying in the cow's ID into the control pad from a leg band, a visual cow number. Then we have a human source of error. Most likely these are transpositions, things like that. This is just an example of a meter performance report from a manufacturer that we use in the US. This report, I have 20 stalls listed. I've seen a herd that has had 320 stalls listed. And this report is size neutral. Obviously, you'd want to use caution if you had a herd that only had 2 or 4 milking stalls. But for the purposes of fitting on the screen more than anything, I'm using this report. As you can see here, on the left, we have the meter number, the stall number identified, and here's our calculated deviations over 10 milkings. This is a report that we would consider acceptable for as the data and have confidence in the data we're bringing in. Another example of a report in a very similar construct, this is a report from a third-party software vendor, common in the US, and for the rest of my illustrations, I'm going to use this layout because it also includes the deviations for the individual milkings on the bottom. Useful tool for troubleshooting. This report obviously relies on a solid interface with the manufacturer's software to be accurate. Real quick, I think one of the key points is when we have a deviating meter or stall on the report, it does not necessarily mean that the meter is out of calibration. I would caution you, though, that if you have 1 meter out on the report, chances are the whole report is unusable because this is a calculation and is derived on the behavior or the performance of all the cows in the herd on those days. What it really means, it's time to be a detective, isolate, correct, minimize the errors involving our dairy manager, representatives from our herd recording organization, and then also we may need to involve other parties, the milkers that were handling the cows to help quantify unique things that happen, or our representatives from our equipment manufacturer to solve software interface errors there. In the US, we recommend that these meter performance reports cannot be used with herds that have incomplete identification or challenges to their EID system. If they have non-communicating controllers, there's no way to get the data across. I think that seems rather logical. If we have 1 or more missing out-of-service meters. And finally, herds where we don't have all strings are not milked at the same milking frequency. It is typical to have some strings milked 6x and some 3, some 4, some 2, some 3, some 2. Many times it relates to the number of hours in the day and what's available to milk the cows. Now, personally, I think we can solve some of these issues with some additional logic in the system. The next 3 or 4 slides, I want to illustrate some sources of verification, talk a little bit about the ID system. Things that we typically see would be inaccurate ID reads from an automated system. For example, cows that appear in one order, but the actual order is a different order. We have incomplete herd IDs. We have duplicate animal IDs that are put in the system, and data entry errors. In a case like that, we get a report that looks like this, and you'll see that almost every value is a plus. What was happening is if there was a new cow that came in the system into the parlor, and she was milked at that stall but did not have an ID, the milk weight that was measured by the meter was added to the previously known cow that went through there. So in some cases, we'll have 3 spaces between valid IDs, so you'd have a cow that have 240 some pounds a day. Obviously, this report would basically be a signal for the recording organization that they need to look at an alternative before accepting the data coming through the system. The next system is just some source of variation would be the equipment. In some cases, we'll have reattachment of milkers, and that milk weight from that first session will be the official milk weight, and that second portion after the cluster was reattached is not added to the weight. Of course, any good manager with a treated cow with a potential antibiotic residue, many chances are that cow's red, but the milk bypasses the meter. So she would have a 0 for a weight. And test day behaviors, just the additional people, everything going on, sometimes affects the letdown on cows. In cases like that, we'll have a report where we'll show some meters in line, but others that just show consistent deviations by the stall. This is probably the toughest one to quantify, the toughest one to investigate, but the lines of communication are key here. Real quickly, if we have meters that aren't installed properly, we make a modification of the milking system, or we actually have a meter out of calibration, you'll get a report like this. And in this case, you see meter 4 right here is consistently out by 30%. This truly was a meter that was out of calibration and needed service. Two quick other examples. If we have a missing milking and we're using a multi-day average, obviously from 10 milkings we're missing one of the data points. That data would be unacceptable. And if we have a software or communication error, we'll have basically missing observations for stalls. So these are concerns that we look at. And I think bringing it all together, I have a few considerations on meter performance reports. A number of advantages. They're low cost. The frequency and the ease of access by both the dairymen, by our DHI or recording personnel is great. We can shorten that turnaround time for repairs and monitoring from an annual water test calibration to basically almost instantaneously. We can identify weaknesses in the system. I think we can build value in what we do in recording programs. And with each test day or herd recording day, we have an assurance of data validity. On the backside, it does not indicate whether or not this meter is operating within tolerance. Rather, it's a tool, it's part of the process, and it's not the answer. Really, we need to have communication, interpretation, action, and follow-up. And I can't emphasize enough, it doesn't replace the installation tests, it doesn't replace routine maintenance to those meters. Thank you.